So hello fellow Earthlings, this is Earthling 6455463728, and I was thinking the other day, as the title may or may not say, that Silicon AI is a bit of a joke. I feel that we are marveling at this thing that we're created, and we think that it's so amazing. And I think because we are so used to reality and the pace of Silicon AI development has been so amazing that we think that between reality is easy because we're used to it. And look how amazing AI is, that it's going to be able to bridge the gap and be, well, it is useful, but per unit energy, is it useful? As far as I know, our human bodies and even our brain use a very, very small amount of power compared to a supercomputer, let's say. And in many ways, what we do surpasses so many different supercomputers, and the calculations that we perform in our brain, or at least the processing that goes on in our brain, exceeds all of these supercomputers that we have out there in terms of the amount of different calculations and connections that we have in all of our neurons and all of our brains consuming this small amount of power. I think wet AI, biological AI, I think that far supersedes anything that we could do on a silicon chip. I mean, I guess I would have mentioned this before in terms of why I thought that slavery will come back. Because if you put two computers in a room and you leave some food and nice music, in a year you're not going to come back with another, and there are not going to be three supercomputers there, and yet that's how we've gone from however small number of human beings there were to being almost 8 billion of us. So, and then I saw a video recently, and in the video they were talking about proteins and the fact that proteins work in terms of a hand-in-glove process. The protein connects to whatever target protein, I suppose, or target molecule that it's supposed to connect to, because it fits like a lock and key. Click. And then whatever is supposed to happen, if the protein is an enzyme, and it encourages a particular reaction to happen, that goes on and it happens. So, in a way, that protein is like a calculation. And for every protein molecule that you have that number of simultaneous calculations, in a way, happening at the same time. So you have a parallel programming going on. In our body, if we have, I think, what is the order of it? 30 trillion cells are in our bodies. We have, and in each cell, there are so many different reactions happening simultaneously in each cell, and we have 30 trillion of them. We have, let's say it's 1,000 reactions happening at the same time in a cell, which I'm probably understating it, because in each cell there can be dozens. I mean, in an egg, an ovum, I believe there are something along the order of 1,000 different mitochondria. So definitely, more than likely, there's at least one reaction happening with each mitochondria. So let's say it's 1,000 happening per cell, and it's already 30 trillion cells. So it's something like 10 to the power of trillion is billion is let's say 30 to the power of 30 by 10 to the power of 15 different reactions that are happening in our body simultaneously. And let's call each one of these reactions some like parallel programming, because it is. All of that's happening. We have an amazing supercomputer, in a manner of speaking, in one of us. I mean, it seems like, and I know that quantum computing is supposed to be this thing that we just can't imagine how amazing it's going to be. I wish I had a tighter grasp on it to be able to speak to what it's supposed to be accomplishing. But even in that, there's supposed to be limits, But what if we can get somehow a yeast with the volume of a human being performing calculations that we want? So we can have, I don't know what the size of a yeast might be, but 30 trillion individual yeast performing parallel processing. I wonder what that would be like. And obviously that wouldn't be using very much energy. It would just be using however much sugar, or you have a vat the size of a human with a bunch of yeast in it. Well, I guess bigger than the size of a human, because we're pretty dense. So the vat could be a lot bigger. And in order to have the same, let's say, number of cells. I wonder if that would challenge quantum computing. Especially, well, no, not as far as they've said in terms of it. But quantum computing seems like such a difficult thing to accomplish. We've been told that it's so difficult, that it's so hard, because number one, you need to have a very, very sensitive system in order to be able to use this quantum computer, because you're actually working with atoms. I don't think it's even molecules. I think you're working with atoms. So imagine if you're doing a calculation, and while you're doing a calculation, next door or close by, somebody's playing loud music. How are you supposed to read your qubits with that kind of vibration that's on the order of more than molecule size of vibration, and you're supposed to be reading qubits? I don't think that you're going to have any kind of quantum computing in your a PC or a smartphone at any point, because you're not. The slightest vibration that you do, and then everything needs to be cooled cryogenically so that you can reduce vibration still. That's not coming to a smartphone near you. And I'm not seeing anybody going down the road to create these biological computers. And maybe it's me, but it seems like something in our own image and likeness. It seems like somebody should be pursuing this. And if you have something that is a biological AI, it would be so, number one, we'd be able to replicate it very easily. We'd probably be able to have some kind of supercomputer that could sit in your hand, and when you drop it, you probably would be able to continue using it. Maybe there might be some kind of an interface that touches your brain, but having all of these, and that's another thing. The interface, I think Elon Musk has this company called Neuralink. And the problem is they're trying to interact silicon with us. And now you have to have wires, and the wires have to be in the environment of our brains, and they have to be able to stay in that environment and not damage our cells. It seems like a big ask. I think that if we were into biological computing, that Neuralink would be able to, I think things might move a lot faster. But because I think silicon probably has its place, and biological computing probably has its own place. And yet nobody seems to be going down that path, at least that any news agency is reporting on. And it seems like it's going to use less energy, probably going to be less harmful to the environment. I mean, making silicon and computers and all these other things, they seem to take a lot of mining. I mean, if you want to create another human, that probably isn't going to pollute the environment too much. If you want to make a new computer, I mean, you need special facilities in order to make the silicon chips. You need to have a variety of different components. You need capacitors, you need resistors, you need the transistors that are on the chips, you need inductors, you need lead, all of these things. You need the whole PCB board. It's not a simple thing. And it definitely, all of these different components that you have and put together, they're definitely going to be harmful to the environment. I don't know, why isn't somebody training a yeast to count? Why aren't we doing something like that? I really don't understand, and I really do think that biological AI would be so much better, and somebody should be teaching yeast to count and do differential equations and whatever else. And maybe I'm crazy, but I don't see silicon as our future. And I don't see quantum computing as our future. Anyway, guys, I don't expect any of you to listen to this. Nobody is listening to any of my stuff. But if you one day end up listening to it, wish me lucks. You can like, unlike, comment, subscribe, and or share. Peace.